We're going to study today's work by looking at an example of Pete and the Jeep tours that he conducts. He will not have a Jeep tour for less than 2 people, so here's the options: 2 people, 3 people, 4 people, 5 people, and 6 people crammed into a Jeep on a tour. Does not sound fun, but whatever. Maybe he has large Jeeps. And here's the probabilities, so jot those down. Can you read my numbers? That last one's a 0.05. The one before it is a 0.20. The mean of the Jeep tours by Pete's is 3.75 persons. And just hope you're not the 3/4 of a person. The standard deviation is 1.090. And I squared that to get the variance. So I write it with this symbol. So I have all the necessary data there. All right. So Pete and Aaron are engaged. They're in love. Oh. And Aaron lives far away, unfortunately, during the engagement. And she also conducts Jeep tours. So they're trying to save up a lot of money so they can get a house or whatever. So Aaron's Jeep tours in another section of the country. Please copy this chart. She has 2, 3, 4, and 5 is the only options she offers for people, and 0.3, 0.4, 0.2, 0.1. Those are both legitimate probabilities because they add up to 1 and follow the other rules of probabilities. The mean of Aaron's operation is 3.10. The standard deviation of Aaron's operation is 0.943. And the variance, I got that by squaring it, is about 0.89. So, because they are going to get married, we are going to take the random variable, I'll call it P for Pete, and add it to the random variable E for Aaron. So we're going to total their operations. They're going to throw all their profits and so forth in the same pot and save up for that dream house. So look at the total here. So first of all, I want the expected value when I add 2 completely different random variables. So I want the mean of the total of the 2. Does it surprise you that the mean of the total is going to be the mean of Pete's plus the mean of Aaron's? So, it probably does not. Somebody get me that total. I don't think I did it. So I need 3.75 plus 3.10. So maybe I can do it in my, all by my lonesome. 6.85. All right, 6.85. So if ever I give you in any problem or any situation 2 random variables, you know the mean of each. To find the total mean, the mean of adding the 2 random variables together, you just have to calculate that. How else could you do it? 2 times 0.05 plus 3 times 0.25 plus 4 times 0.35 plus. So, but look how much simpler it is. We already did his, we already did hers. You just add them together. So the means are cooperating. The means are cooperating. So what does that infer about?
Deviation won't cooperate.
Yeah, but we're gonna beat him until we understand him at least. Let's talk about standard deviation. It's kind of hard for me to explain this, so I'm gonna do something simpler first that I can explain, and then just say, and standard deviation works the same. So that's a trick us teachers use when we can't explain something. All right, so let's talk about just spread. Spread is the difference from the lowest to the highest. So Brandon, check out Pete's tours. What's the lowest and the highest on his customer number?
2 and 6.
2 and 6. So looking at his goes, Pete's goes from 2 to 6. That's the range or the spread. And so that's a spread or a range of 4. All right, so now let's look at Erin. Erin's goes from 2 to 5, so her range is 3. Looking at that, let's look at the total. Suppose we were looking at the very lowest, because now when we're adding them together, the very lowest combination of Erin plus Pete is what? Julia, what's the lowest of adding the two together? So you're looking at these numbers, adding them to these numbers. What number is the very lowest possible?
Is that if I multiply the...
Not multiply, we're just adding. So I just want the, if we are adding Pete's operation to Erin's operation,
The whole
any,
thing or individual ones?
yeah, an individual, what's the lowest day that they could see as far as customer number?
0.45?
No, not a point, because I want a number of
Like the
people.
lowest number of people that Pete can take is 2, and then the
So
lowest
together
number is
of people,
Yeah.
4.
Right, exactly. So if I'm looking at the lowest, so that would be for them total, 4 is the lowest. Could there be any other lower number than that? Because he won't take 1, she won't take 1, so the lowest is 2. So Elena, what's the highest combination between the two that we could get? So one day he might have 2 and she might have 3, and that would be a 5 for our total. One day he might have 5 and she might have 4, that would be 9. So what is the highest possible combination?
So it would be 11
And where'd you get that?
from 6 plus 5.
Right, 6 plus 5, so very good. The highest in his possible and the highest her possible. So do you see then the total range could go from the lowest 4 on the combination to the highest 11, which is 7. Could we have done that an easier way? Do you notice that Pete's range and Erin's range add up to the total range? So that's not too bad, right? Guess what works that way? It's not standard deviation. What's another measure of spread that we study? It is variance. It's variance, and remember I write the word variance. The variance is written with this symbol for not Erin, for Pete. It's standard deviation symbol, sigma squared. So that's what we use for the symbol for variance. So Pete's variance and Erin's variance to get the total variance over here under the T, we can do just like what we did with the range. We can just add their variance. So remember I gave those to you. So 1.188 for Pete and 0.89 for Erin. So variance is fine, it works the same. So if you would add 1.188 and 0.89, somebody get me that. Are we timing this?
I just realized I haven't been timing, but probably should stop it now.
Okay, all right, we'll be back.